Okay, so we have about a half an hour discussion wrap up for the community testbed development aspects. And I know that, so just again to refresh your minds, there are, in RCN, the interesting problems have been at the interfaces. So there have been working groups, especially in networking and signal processing side. Marco and some other folks, Ismail, and even some of the UW folks, Seattle, Tom Henderson, have been really looking at that, and they've been doing end-to-end simulation, a lot of work, interesting work going on there. And then there's been more recently hardware signal processing that has taken traction. And so yesterday the idea came that, okay, there's a different groups out within the country or in the U.S. are developing these test beds. Berkeley, Wisconsin, and I know that Jananth at CMU, he's developing some, and I'm sure there are other folks. And some are building the whole thing, others are taking eval boards from, Velocity, Qualcomm, wherever, and you're just playing with networking protocols. And the idea here is there an interest to have an end-to-end simulation, or not simulation, a testbed platform, which could be, I don't know how it would look like at the end. It could be in one place and it's accessible like a mini version of PAR or whatever, or ideally at a cost point that can be replicated in a modular fashion at different institutions. And so the first thing is, what we want to gauge is interest, and two, who are the people, who are working on, RF, and then ADC, FPGAs, because you'll need that, and then the networking protocols. And who would be the people who would be interested in actually involved in being a part of a team that actually creates the specs for it and builds that test bed, and then who would be interested in using it at the end, and then eventually it could also go into, provide technology for power platforms. So first whoever I want to hear from folks here, how many people, are there any people involved in building it, and who would be interested in using it, and so on. So I know that there's you.
Hi, so I'm from mmW Networks Institute in Spain.
Okay.
So we have like two different tracks right now. So on the one side, we are working with off-the-shelf devices. So using 1180 devices with the Qualcomm chipset. So with these ones, we are just doing we have the whole protocol stack. So we are trying to do some reverse engineering in order to be able to obtain data and also modify beam patterns and these kind of things. But of course, it's very limited. We cannot do whatever we want. And on the other hand, we are building right now, we bought a large FPGA and also an antenna array front end of 60 gigahertz. And we want to do a platform with that. And we are trying to do this as an open project to be able to collaborate among different institutions.
Very good. So you bought an FPGA and an antenna array for 60 gigahertz.
Yeah.
Where is your antenna array from?
So we bought the ones from Sivers IMA.
Okay, it's some European.
I think they are from Sweden.
Okay, so it's a single beam phase array, 60 gigahertz.
Yeah.
Okay, and then you're developing FPGA solution. All right, very good. So you would be interested. You would be interested in being part of some development like that. And so, do you think your expertise is more? It seems like more on the FPGA and algorithms part, or?
Yeah. Yeah, not on the RF side,
okay.
For sure.
Okay, very good.
More like a networking group.
Networking group. So you can. And do you think you're interested in developing real-time implementation protocols?
Yeah.
Very good. Excellent. Excellent. So we need to get your name, absolutely, and contact. Who else? Aditya, are you interested in building something real?
Yeah, so what? Blow, well played.
A real emulator?
No, so the project that we are running right now is to build a 28 gigahertz array, a fully digital array. So we are basically building these boards that have 4 channels each, and they are extremely small. Like they're going to be 2 cm by about 5. So you can tile them to create arbitrarily sized, rectangular arrays. And so we are working on fabricating this board, everything using commercial off-the-shelf ICs from analog devices and a bunch of other different players. And so we are still very early, but we hope that by the end of the year, we'll have a proof of concept, fully digital array at 28 gigahertz working.
28 gigahertz fully digital, how many elements?
So the thing is that every daughter board has 4 channels,
Yeah.
but you can tile multiple of these daughter boards arbitrarily in both directions to create hopefully arbitrarily sized.
Okay, so it's like you have a basic module which is 4 by 2, 4 elements, full ADCs, DACs, and everything, and power amplifiers and everything in there.
So the board that we're designing right now is actually, it goes, say on the transmitter side, it's 4 channels IF in, and then some reference LOs, and then you multiply the LOs up, and then you mix, and then you filter, amplify, and then you connect it to antenna ports.
Yeah.
And then on the other side, the antenna is going to, so the daughter board has IF in and antenna ports on the outside, like these really tiny SMPS connectors.
Okay.
And then the antenna board on the other side is going to be like just, it's going to have either patches or Vivaldi's or whatever with connectors at the bottom. So you can just like click the antenna on top of the daughter board.
Okay, very good. So you'll have, so this will be a modular, you could scale it up.
Yeah,
so that's fantastic.
So if you want to scale it up, if you want to have a different number of channels, you'll only have to redesign the motherboard, because the motherboard has slots for each of the daughter cards that goes in. So you have to redesign the motherboard. So the motherboard is going to take in baseband IQs in, convert to IF, and then feed the IFs into all the daughter cards.
Okay.
And the reverse process.
Okay, and so this is basically just RF, and you'll have IF interface, and then we can put it to the back end ADC. Very good.
That's it.
So,
I mean, we have nothing working, I must say.
Oh, that's okay. We know that. I mean, we'll make it work.
And so, and I'm the engineer, so the probability of failure is
High. All right. No.
quite significant.
No, that's very good. No, that's great. So you're in. So that's great. You'll be another RF player. Potentially, so that hopefully, all
we're
right.
new to the RF game, so take
No, I
everything
think
say
this
with
would
a
be,
grain of salt.
there's a lot of collective expertise
So
on that.
I wanted to maybe talk about 2 initiatives that I've heard about, but I don't know fully the status of them. On the network layer stack, there's out of Raymond's group, the OAI from France, the organized for open air interface.
Okay.
So they've already built a full new radio stack, but below 6 gigahertz. And my understanding is that there's some effort already to try to use that above 6 gigahertz, which is actually the protocols don't change that much. You just have to speed it up. So hopefully that can cover the upper layer stack, to say Mac and above. And then I've seen this. So does anybody have much experience with the MathWorks side? Because MathWorks did provide an LTE.
MathWorks?
But the way that you could put the whole blocks on the LTE part and then simulate and then actually synthesize from that FPGA code, right?
Beautiful. Yeah, I think this is something I'm going to loop back with them, because
I know they have a 5G effort too, and I know Mickey, you would talk to a little, have a little experience with that.
MathWorks, we will loop back with them, because you can create HDL code from MATLAB.
Basically, we are evaluating the 5G toolbox from MathWorks to using exactly that, the HDL, to go from Simulink to HDL directly.
Beautiful, yes. So I think I wanted to get MathWorks folks here, but I just didn't get to do it in time. So we'll loop back with them. So how has your experience been so far?
It's in beta, so basically we're working on it. Okay,
good. So we'll keep you in the loop too, because I think that could be useful. Because I think I can share, in our group, we were working with Xilinx boards, and we use Simulink as well, and their system generator as well. And in the end, in some cases, you have to just code it up yourself, or system generator works quite well too. And Simulink is good, but when you come to tricky timing stuff, it can run into trouble. So But I think MathWorks may be interested in putting some resource in it too, so we'll loop back on that. Cool. Okay, hang.
Actually,
So who's Ismail? You're taking. Okay, so yeah, very good. So all the players, let's keep noting. So, okay.
so we are more focused on network stacks. So we have a project with Army right now. So it's not related to millimeter wave right now, but what they want to do is to use 3GPP stack, but use their own radio. So basically what we are doing is we use OAI stack, all this LTE stack, and PDCP, all these things, but combine it with emu. So this emu is this Army research simulation or emulation platform. It can run on the multiple virtual machines then connected by the Ethernet. But underlying radio, so could be any radio. And right now, we use a wireless LAN radio, but on the top is 3GPP stack.
Okay,
So,
and this is also for real-time implementation.
so they don't have real time right now. So requirement right now is, but you can run on multiple machines to set up this simulation platform.
Okay, so I think this could be. I wonder if that is more tied into something like NS3, or would it go into some testbed where we would want to. So testbed, it's another thing I want to emphasize, and this was one of the, and I don't know if Kate is still here or not, but there's also this channel measurement, right? So once you have your testbed, you have a channel sounder too, whether you like it or not. Channel estimation, and you can do all sorts of channel measurements. So there's a non-real-time operation used too, where you just get traces and you can process. So everything. So you could be, so you'll be a good player for the networking protocol.
Yeah,
side.
I think that this is one step further than NS3. NS3 is a more event-driven simulator.
Yeah.
Right, but this thing, the emu is also a simulator, but somehow you can set up on multiple machines. The underlying, you can use the Ethernet to simulate, put something to simulate the channel, and also you can plug in different radio. So right now we just use wireless LAN, because that's already built in.
So is that emu? Is that an army thing?
Yeah, I think the emu is one of the simulator came out from Army research or Navy research.
And it's open. They are willing.
Yeah,
to share?
that's also open source.
Okay, okay, very good.
Right now they have a very simple built-in ad hoc wireless LAN-based thing. On top of that, so we are trying to integrate OAI stack, the LTE stack. Yeah.
Is that the same one that Sandeep was mentioning? OAI open air interface?
Yeah, right, yeah. But
Okay.
OAI is right now is running on USRP platform, So we are trying to do is to take out the radio part, but put any kind of other waveform generator in. So because they call the simulator. So the simulator you can build some adaptation, things. So.
All right, very good. So I think we will, you'll be on the networking side. All right. Who else? Yes.
Okay, Ahmed Suleiman, Embry-Riddle Aeronautical University, Arizona. A few years ago, we were working on spatial modulation scheme, and there were a lot of theoretical, input on the scheme, but no one had, presented a result from test bed. So what I did was to bought some off-the-shelf WARP board developed by Rice University, and we were able to put this work in 2x2 MIMO. We extended it to 4x4, and we were able to collect some real-time data from this to show that this system actually works. So this was an example of MIMO-based or spatial modulation-based test bed. I developed it. It works at 2.4 gigahertz, and we could also go at higher frequencies, just about changing the antenna.
Well, I think so. This is actually a good point, but warp boards will not work in this. So this is like building a warp board, version of warp board for millimeter wave. So warp sampling rates are not going to be fast enough. So that's why you'll need a dedicated FPGA development. And this may also be true for some of the networking protocols. It's non-trivial because your data rates are very high, so we'll have to think about, conceptualize, what that architecture looks like. But, yes, so this would be developing a new warp board.
Okay. So on the RF side, like I was telling you, channel sounder is all about just, one can build them oneself by putting local oscillator, signal generator,
well, that's exactly what.
Receiver, and you can choose the frequency as much as you want.
Yes.
Now, developing that into MIMO is also possible. Right now, we're using one transmit and one receiving antenna.
Okay, so you could potentially contribute to the RF part too, because one of the things is that we have discrete solutions, and we could, and there's different front-end architectures that could be integrated into an integrated RF board, which could be used. So, for example, Wisconsin could provide lens arrays for beamforming, and, Berkeley could have phase arrays, or Aditya could have a phase array on steroids. Fully digital beamforming phase arrays. Okay, who else? Ismail, yes.
So I think we have a couple of platforms that can be of relevance. One of them is, maybe I can speak also for my collaborators. We have a project from NASA with David Matolak and Hanimer Puyan from Boise State. So we are developing channel sounders, which will turn out to be also some test beds at 3 different frequency bands. What we have at NC State is PXI-based platform, which we already started doing indoor measurements. We have a lot of, we are collecting data. These are for now based on horn antennas and physical steering. We are looking into now moving outdoors. We have our FCC license at 28 gigahertz for a year. And Hani already is doing measurements at 60 gigahertz. He has a Keysight platform at Boise State, and David is doing 90 gigahertz from Rode Schwartz. So we will have 3 different platforms. The main idea is we will go to airports together, and we will do experiments in the same exact environment to see how the propagation they change in these 3 different frequencies. We are interested to do air-to-ground scenarios, but that's not easy, obviously. But I would like to echo what you said before. Once you have these test beds, you can use them as channel sounders. If you have a channel sounder, you can use them as test beds. We are also looking into using our platform for drone detection. I don't know what will be the range and how feasible it will be. But we also had some tests for example, indoor mapping. We were trying to map the size of a room in an indoor environment. We sent a white paper to DoD, but it didn't go through. So that's one platform we have. We have the second year funding coming, so we are looking into what phase arrays we can integrate to this platform. We are trying to get a quote from Anokiwave, but we have been not successful.
Good luck.
So if there's any of you have expertise on or suggestions on phase array platforms for integrating to NI, that would be very helpful for us. We also have a USRP-based platform at 60 gigahertz with the Pasternak, Rubik. We also have some measurements. It was the main motivation for developing that was carrying them with drones. So there was a poster yesterday from NYU. We have to, for one of the projects, we have to do air-to-ground measurements. And recently we started looking into doing an FPGA-based, I don't know if you want to talk more about that, but with a master student, whether we can do it with FPGA. I'm not sure where it will go, but that's another thing we are doing. And the last thing is we had evaluation boards from TensorCom based on 11AD. But what I understand is they are shutting down or going out of business. So one of them stopped working. I think they were very reasonable for doing air-to-ground measurements. The range was up to 500 meters, but we couldn't do air. They stopped. We have a paper, a simple paper in VTC coming up based on the measurements with those. But so those are some platforms we have.
Okay, so that's great, and I think that actually brings up another point that people who have already invested in, so one point I want to clarify, if you have a test bed, it's also a sounder. If you have a sounder, that's not necessarily a test bed, because sounders, you cannot test all the protocols. So it doesn't necessarily go the other way. So for example, people who have already invested in NI equipment, right? They cannot do networking protocols where you say, hey, you can put it whatever you want. So with your PXI, if someone built a FPGA-based networking interface, you could use that, for example. So I think, and then the front-end RF could be useful for you too, just like you said, phase array or lens array that you could use. So I think that's the modular part that could be really useful here. But where would you think your main contribution would be? In processing or developing networking protocols and FPGAs, or where could you contribute? Or maybe you'd be the user.
I mean, it can be user, but when you say test bed, this is a communication test bed all the way going to networking layer, or can you consider, for example,
what I'm
interested in sensing localization type of applications in indoors, so test bed can be many different things, like it's not necessarily networking test bed.
So that's a good point, and I think what I'm initially thinking is end-to-end communication with real-time implementation of protocols, where you could play with it, and it could also be, for example, I can just, our plan for Wisconsin has been to create these access points with beamforming capability and then put them in different buildings and create a virtual network of 3 or 4 access points, and then put you a, mobile access devices or mobile stations accessing and creating networking protocols. So I think that's what I'm thinking, which potentially could be replicated. But this will be fleshed out as we go along.
So it's also, one other thing we are thinking is we have right now, it's obviously channel sounder unidirectional, but if you have 2 more pairs, one more pair of millimeter wave radio heads, we were thinking of extending it to bidirectional, then it becomes the uplink and downlink communication. So that's also...
Yeah, okay. Shin?
So far, we mainly work on the implementation or just simulation on the MATLAB platform. We implement all the channel models and also 11 AD and AY kind of protocol stack. I think we can extend to the testbed. The reason is testbed has too many platforms. We don't know which one we can apply, which one will survive. That's a major problem. I think it's no problem. We can extend to FPGA kind of things, but really we have to choose something will work, because you can see the different things. I don't know which one will work. But the protocol itself, a lot of cases, doesn't really depend on those platform. To some extend the simulation part actually is challenging. You have to build something. And for channel, for example, you can measure, but in order to do the simulation, you actually have to understand channel model to actually build it.
Yes. So I think you could, So that could be also the end-to-end simulation that Marco is doing. But I think that brings up another interesting point where a lot of us will have simulation software in MATLAB. And I think if math works, especially if we develop it in Simulink, or maybe their HDL coder is even more advanced, so I'm going to loop with them. Maybe next time that's an action item for the organizers to have them here for sure, to see how much of that could be transported onto the FPGAs to create an HDL code. But some of it would be non-real time, some of it would be real time. Okay, so we are, Marco, yes.
This is something, I met these guys, ITRI, I don't remember where, from an Asian. Yeah, right?
That's from Taiwan, right?
What's that?
That's from Taiwan, right?
Yeah, exactly. And they have a platform, a fully MATLAB-based integrated. It's very interesting. I think, they should...
Yeah, actually, I know the team working on, they have a platform supporting millimeter wave communication. Everything is implemented in C and MATLAB. And now I think I spoke to them because I work on the OAI implementation. We're trying to create an interface to integrate OAI on top of their millimeter wave platform. And last time when I met them in June, OAI workshop, I invited them to join the workshop this time, but they are busy for MWC. But they definitely told me that they are interested in join this community.
It's funny because I invited them too, and they told me that somebody else invited them. That was
I think that's me.
Okay.
Yeah.
And there's a very nice presentation that they public domain that I found that's from the OAI meeting. It's very nice.
Yes.
Yeah. So I think we should
Now,
take a look. I
would
will
be-
share.
Now, this is below 6 gigahertz right now with 56 megahertz bandwidth, but they could be a partner in helping us build some of the components. Very good.
It is because, like in Taiwan, the license band is not in 60.
Yes.
So they choose lower
Okay, very
frequency.
good. So we'll loop with you too. Who actually, before I forget, that's also an interesting point that a lot of companies are also now putting out eval boards, including analog devices. And so we need to be, there's a lot of things that's available out there, and some of you will have information on that. Anybody else who wants to share who is working on test beds or would be interested in this effort? So if we had this available, how many would be interested in using it? A lot more. Okay. So I think what we're going to do is we'll definitely follow up on this because and with a little more structured information so that we get information from you, get a kind of a mailing list for it, for a group setup, so that we can develop a framework, what this looks like and what the specs would be and build on it. And our goal is to maybe have definitely next steps for the next meeting, which is 6 months, and maybe in the 6 months or a year at most. We have 2 meetings left, so at least at the latest, at the end of that, if the community wants to do it, then there should be a plan and the players identified. So, yeah, okay. Any other comments by anyone? Do you want to say anything, Greg?
Yeah, I mean, I think this sounds like a good plan. I think kind of coming back together and making sure that whatever comes out is modular and has well-defined interfaces will kind of be the biggest key to success. So, if everything is kind of undocumented or just kind of ad hoc interfaces, one person might get something cool to work, but it will be like extremely hard for everybody to adopt. So we just need to be very kind of cognizant of that.
Absolutely. That's a very good point, and I think that's an excellent point. Yes, I know exactly what you mean. And I think, but the most important, the most beautiful thing about an RCN like this, and this is my experience first time with something like this, is that the collective expertise in the entire room. I mean, it's like for every interesting or important challenge, there's somebody who is interested and has the skills to do it. So I think that's what makes it successful. So it'll be a team effort. So thank you very much. And I want to thank the local hosts again, Sandeep, and I don't know where Pat is. Pat Donahue has done an amazing job. She's the one who's the chief organizer, and then William, who was the AV guy. I know today we have another person. Thank you. And also, where is Adam? Yes, thank you, Adam. So let's give him a hand of applause.